let's take a quick look at this question. In this question, we are asked, in the diagram above, this is the diagram, okay? This is the diagram. Deduce the activation energy of the uncatalyzed and catalyzed reaction. We are asked to find the activation energy of both the catalyzed and the uncatalyzed reaction. Now, firstly, understand what activation energy is. Now, activation energy, the minimum amount of energy that is required for a reaction to start. Now, it is called the energy barrier. For substances, when two things collide together to react, they must overcome energy barrier. Okay? Now, that energy barrier is what we call activation energy. Now, there are some factors that affect the rate of chemical reaction. Remember, this topic is chemical reaction, rate of chemical reaction. Now, number one of the factor, temperature, we have concentration, we have nature of reactant, we have sunlight, we have catalyst. Here, this diagram is of what? A catalyst. Okay? Now, what does a catalyst do? A catalyst lower the activation energy. That is, it provides the alternative pathway for the reaction. Affect the rate of a reaction by what? By lowering the activation energy, so that a product can be formed faster. So in this way now, if you have to indicate the one that is a catalyzed and the one that is what? Uncatalyzed. Now, when catalysts have not been added, you can see that from here, remember, between the reactant, look at the reacting particle here. From here, between here to this side, to this end point, look at this end point here. That is where the activation energy is. Between here, from this 300 to this 100, that is the activation energy of this first one. Why the second one, from here to this side, this is the activation energy of the second one. Okay? Now, if the time that a catalyst has not been added, the activation energy is at this point. I told you that the catalyst help by lowering the activation energy. Do you get that? It lowers the activation energy so that product can be formed faster as soon as the particle begin to collide. Now, the time that catalyst has not been added, look at the activation energy here. Do you get that? So we term this one to be what? Uncatalyzed. Uncatalyzed. Now, when the catalyst has been added, it now lowers the activation energy. You say that this one is what? This one is catalyzed. So we are going to find the activation energy of the uncatalyzed and the catalyzed. Now let's calculate it. In the one of uncatalyzed, I told you that between here to here is the activation energy, from here to the here. So you trace here. So here is what? 300. Uncatalyzed is equals to 300 minus, from here, the point here, look at the point here is 300. Minus what? Minus 100, minus 100. Where the reaction starts is 100, so equals to what? 200 kg. Now let's look at the one of catalyzed. The one of catalyzed, look at the activation energy here from this point to this point. Now trace this point now to the energy side. Look at, you get to what? 200. 200. You minus it by where the reaction starts. Where does the reaction start? We have 100. So catalyze is equals to what? 100 kg. Therefore, our uncatalyzed is 200, while catalyzed is what? 100. So the question says, in the diagram above, deduce the activation energy of the uncatalyzed. Uncatalyzed first, and the what? And the catalyzed, which is what? The uncatalyzed is what? 200, which is this one. And the catalyzed is what? Is 100, which is what? So our correct answer is what? Is A. For more of this video, do well to like this video, share and comment. Thank you and God bless you.